Hello children, welcome to Zero Panic Maths. In today's session, let us start with a new chapter, chapter 4, Exploring Algebraic Identities. In class 8 or in your previous grades, you might have studied that what is an algebraic identity. Okay, so this is an algebraic expression that, or it is a special mathematical rule that makes it easy to simplify complicated calculations and also help us work efficiently with algebraic expressions. So complicated calculations we can easily resolve, and we can work on some algebraic expressions also. We will see some examples also later. Okay, now let us take one simple example to understand what exactly is an algebraic identity. Okay, so listen to this example carefully. The steps I have written here, let us read one by one. Consider any three consecutive square numbers. Okay, so I've taken the three consecutive square numbers of 1 square, 2 square and 3 square. Okay, these are the consecutive three numbers, 1, 4 and 9. That is the first step. Second step is add the smallest and the largest square. It means the among the three you should add the first and last. Okay, so that will get us, see, 1 plus 9, that will get me 10. Okay, now see the third step, then subtract the twice the middle square. The middle square is 4, twice of that is 4 into 2, that is 8. So this actually leads to 10 minus 2 into 4, which is 10 minus 2 and is equal to 2. Okay, now, why I'm giving this example? Because this is a specific kind of identity that if you take any three consecutive squares and add the first and last, okay, and second step, subtract twice of the middle square from that sum, okay, you will always get the result as 2. That is what the characteristic of this identity. Okay, that is why I'm giving this example. Now let us try the same example with the another three consecutive. Okay, so since this is an identity, the important characteristic of an identity is it will be true for all the values. It will be true for all the values. The same characteristic applies. So that's why, well, let us verify this identity with three more consecutive. You should take only consecutive square numbers. Okay, remember that. So I've taken 3, 16 and 25. This is 3 square, 4 square and 5 square. Understood this? Okay, now let us add the first and last. What is that? 9 plus 25. Okay, 9 plus 25 minus, what is the second step? Second step is subtract twice of the middle. Twice of the middle is 2 into 16. Middle is 16 right here. Okay, so what is 25 plus 9? That is 34 minus 16 twos are, that is 32, and what is the result? The result is 2. Now this, you can take some more consecutive numbers, consecutive three numbers, and try this identity. This is always going to give you the value as 2. So this kind of an expressions are equations are called as identities. Okay, now let us take some examples and work on some examples and the identities that you might have studied in your previous class. Okay, now one of such example is this. Okay, revisit some algebraic identities that you might have studied in your earlier grades and try to visualize them using the geometrical models. Okay, this is very, very important and very interesting also. You can see that you remember this algebraic formula. You remember this algebraic formula or algebraic identity, that a plus b whole square is equal to a square plus 2ab plus b square. We can verify it with some values. A is equal to 2 and b is equal to 3 later. Okay, we can verify this. I think you remember this formula. Okay, now let us prove this formula with some geometrical models. Okay, see this. This is very, very important and very interesting also. Okay, now let me consider, to prove this, let me consider a line segment of length a. Okay, let us consider a line segment of length a, and beside to that consider another line segment of length b. Okay, Assume that this is of length A and this is of length B. Let us put that same line of length A vertically and beside to that length B vertically also. Okay, so this is a line segment. Okay, of what is the overall length of this line segment? Then A plus B. This is A plus B. Okay, and this is also A plus B. Correct? Okay, listen to me carefully. Okay, now let me just construct this as a square. And what is the area of this whole square? Because the side is of length A plus B and A plus B. What is the area of the square? The overall square is A plus B multiplied by A plus B. The area of the square is side into side. Okay, so the total side is A plus B, A plus B. So therefore I can say area of the square, area of the square is equal to, area of the square is A plus B multiplied by A plus B, and that will give me A plus B whole square. Is it fine? Okay, now let me just draw a vertical line here with width B. This is a line of width B, so I will just draw a vertical line and also a horizontal line with height as B also. You understood this now? Okay, now listen to me carefully. What is the length of this side and length of this side? Assume that this is a square now. The length of this will be B, because this is B, this is also B, it is parallel to it. Because this is B, this is also B, and this is parallel to this. Now see here, it is a square of side A and A, this one, okay, and this is a square of side B and B. What is the area of this? It is A square, because it is of side A and A. What is the area of this rectangle? There are two squares and two rectangles formed by this vertical and horizontal lines, correct? What is the area of this rectangle? Because this is A, this is also A into B, that is AB. Listen to me carefully, okay? Because this is A, this is parallel to this, and this is also A, correct? So what is the area of this rectangle? That is AB. Okay, now B into B, this is a square. The area of this square is B square. Now why I have calculated the area of all this? Because now the overall area, the outermost area of the square is now divided into area of A square plus area of B square, area of this rectangle which is AB, and area of this rectangle which is also AB. Now if you add all the areas, you will get the area of the outermost square. Simple, right? So what is that area? A square plus B square plus AB plus AB, that is plus 2AB. So that's why it is A square plus 2AB plus B square. And this is the proof of this arithmetic identity. This is an arithmetic identity, we call it as, and this is how we proved it by geometrical models. And what are those geometrical models? Square and rectangle. Okay, now I hope you understood this. Now we are saying that this is an algebraic identity, so it should be true for all the values, correct? Let us verify it with a value as A is equal to 2 and B is equal to 3. Let us put A is equal to 2 and B is equal to 3 here. It will give me 2 plus 3 whole square is equal to 2 square, that is A square, plus 2 into A, that is 2, and that is B is 3, plus 3 square, correct? What is 2 plus 3? That is 5 square. And what is this? 2 square is 4, and this is 2 into 2, 4 into 3, that is 12, plus 3 square is 9. Okay, 4 plus 12, 16 plus 9, that is 25, and 5 square is also 25. Now this is how we verified that this algebraic identity works with A is equal to 2 and B is equal to 3. Some random positive values I have taken. You can put in any values, this will be true. Okay. Now let us verify the same identity with negative numbers also. Because we are saying that this is an identity, it should be true for all the values. Now I have verified it for positive. Let us verify it for negative also. Now let a is equal to -2 and b is equal to -3 and verify that. What is a plus b whole square? That is -2 -3 whole square. This is a plus b whole square. Okay. And what is a plus b whole square? A square, which is -2 square, and plus 2ab, that is -2 multiplied by -3, and plus b square. B square is -3 square. Okay, hope you are getting it. Now -2 and -3, that is -5 whole square, okay, is equal to -2 whole square, that is -2 into -2, which is +4. Correct. Now this minus and this minus will multiply each other and makes it plus. Now it is 2 into 2, 4 into 3, that is 12. It is exactly similar to the previous one only. Okay. Now again -3 square is always positive, which is 9. Now -5 square is 25, and this is 4 plus 12 plus 9, which is also 25. Okay. Now verified that with negative numbers. Okay. Now let us verify the same with some rational numbers. Okay. The rational numbers is one is negative -2/3 and another is positive, which is 3/4. Let us just substitute the value of a and b in the given formula and calculate the same value. -2/3 plus 3/4 and whole square is equal to, a is -2/3, that is -2/3 square, okay, plus 2a, again it is -2/3, and b is 3/4, okay, plus b square. B square is 3/4 whole square. Okay. Now let us take the LCM of 3 and 4 here in the left side, which is 12. Okay. LCM of 3 and 4, and it is 3 4s are 12 and 4 3s are 12. Okay. So 2 4s are, that is -8, plus 3 3s are, that is 9, and the whole square remains as it is. Here it is 2 -2 whole square, that is 4, divided by 3 square, that is 9, plus, now you can cancel this 3 and this 3. Here also it is 2 1s are, 2 2s are, and even you can cancel this 2 and this 2. What remains here is -1. So I'll just write this as -1 here. Okay. Now it is 3 square, which is 9, divided by 4 square, that is 16. Now let us subtract 9 minus 8, that is 1, and 1 square is 1 only, okay, divided by 12 square, that is 144. Okay, you remember this? Okay, 1 divided by 144. Now let us take the LCM of these three numbers also. Now 9 and 16, now you can easily get it from here because it is 144 here. 9 and 16, it is 16 9s are 144. 144 will be the LCM of all these numbers. You can verify it later. Okay, so 9 16s it is, and 1 and 144, it will be 144 only. Okay, and 16 9s are, it is 144. Okay, now 16 4s are 64, okay, minus 144, okay, and then 9 9s are, which is 81, plus 81. Now if you calculate the value here, it will be 64 plus 81, which is 145, minus 144. It is 1 only and 144. So it is 1 divided by 144 is equal to 1 divided by 144. Obviously it is going to be true only because it is a proved identity. Okay, hope you understood this. Now what did we verified here is the equation, or we can say the algebraic identity a plus b whole square is equal to a square plus 2ab plus b square is true for all the values. We have verified it with the positive numbers, negative numbers, and even positive negative rational numbers also. So we can say this as an identity. And what is an identity? What is the difference between the equation, an equation, and identity. It's a simple definition. You can see that an algebraic identity is an equation. It is an equation, but its value is true for all the values of variables occurring in it. Variables are a and b. A and b are the variables in that identity, and for all the values of variables a and b, it will be true. That is called an algebraic identity. But whereas an equation, if you say an equation, it will be true for some specific values of the variables. It will be true, but not for all the values, but for some specific values, which is actually finding out the value, exactly finding out the value of the variable. Some example you can take it as x square minus 1 is equal to 24 is an algebraic equation. Okay, because for x square minus 1, if you want it to be 24, I can put x is equal to 5 or x is equal to minus 5. You can say that. You can just check it. 5 square 25 minus 1, that is 24. Minus 5 square is also 25, and minus 1 will be equal to 24. For no other value of x, this equation can be true. Okay, so that is the reason this is called as an equation, algebraic equation, which is true for some specific value, and algebraic identity is true for all the given values. An example what we have seen is this formula, this a square plus a plus b whole square is equal to a square plus 2ab plus b square. Let us see some examples as exercise set based on the same formula. Okay, now before exercise, let us see some solved examples. These examples are solved in the book also. Let us expand this 5x plus 2y whole square with the same given identity, algebraic identity. Here you can say a is equal to 5x and b is equal to 2y. Now we have to, if you want, you can write that expression or the algebraic identity. A plus b whole square is equal to a square plus 2ab. I will not write it again and again. Okay, you need to remember and then just substitute the given values. Okay, now let me substitute. A is equal to 5x plus 2y whole square is equal to 5x whole square. Don't make it as 5x square. Okay, it is square for both the values here, the coefficient and the variable. Okay, that is the one thing that you need to remember and do it carefully. Okay, to a is 5x and b is 2y. Okay, plus y square, y is 2y, y is 2y whole square again. Okay, now why I am saying whole square, you will come to know that. Okay, it is 5 square and x square, that is 25 x square. It'll do the square to both coefficient and the variable. That's the reason I told whole square. Now it is 2 into 5, that is 10, 10 into 2, 20, x into y, xy, 20 xy. Okay, plus 2 square, that is 4, and y square, that is y square. This is the expansion of this 5x plus 2y whole square with a given algebraic identity. Okay, let us do it for 43 square. Now this is a constant and the square of that constant. Now, as I told in the introduction section itself, that these algebraic identities help us in solving some complicated algebraic problems also. Okay, now what we can see one of those, that I want to calculate a 43 whole square. Now, instead of directly calculating 43 whole square as 43 multiplied by 43 only, but let us resolve this by using the algebraic expression, this algebraic identity. Okay, I can say, I should be saying it as an identity, a plus b whole square. Let me write 43 square as 40 plus 3. Okay, it will be easy for me to calculate 40 square instead of 43 square. Okay, and since 3 square is very less number, I can easily calculate the square of that also. Now here a is equal to, now if I consider a is equal to 40 and b is equal to 3, it will be 40 plus 3, 43 square. Okay, now let me write this as 40 square, which is a square, correct? 40 square plus 2 multiplied by 40 into 3, that is b 2ab, and b square, that is 3 square. 40 square is 1600. We can easily calculate because it is 4 square and 0 0. Okay, in front of 4 square I'm keeping two zeros. 2 for 2 fours are 8, that is 80. Okay, and 8 threes are 24, that is now 240. Okay, it will be 9. 1600 plus 240, 1840 plus 9, that is 1849. Now if you calculate 43 multiplied by 43, that will also be 1849 only, obviously. But we have resolved this, assuming that this is a complicated problem, where we can resolve some complicated algebraic problems in this way, okay, by using this algebraic identity. Okay, now let us see. Okay, now we are done with the examples. Let us see exercise set 4.1. Here also we are using the identity, the same identity that what we have proved now, and try to expand the given algebraic expressions. Okay, now these are all same only. Let me do it quickly. Okay, here a is equal to 7 6, okay, sorry, 7x, and b is equal to 4y. Now if you want, you can write this a and b, because I want it to be referred to with the algebraic identity a plus b whole square. I'm writing this a and b. If you want, you can write it, or you can directly expand this 7x plus 4y as a plus b whole square. Okay, that is 7x whole square, that is a square, 2 into 7x into 4y plus 4y whole square. Correct? 7 square, that is 49 x square. Okay, 2 sevens are 14, 14 fours are, that is 56, x into y, that is xy, and 4 fours are 16y square. This is the expansion of this. Okay, nothing more than this, just expanding the given expression by using the identity. Just go on substituting the given a and b values and write this in this format. That's all the expansion is. Okay, now let us do it with these algebraic coefficients. Okay, now I'll not write this a is equal to b is equal to. Let me write this directly as 7 by 5 x whole square, that is a square, plus 2ab. A is 7 by 5 x, and b is 3 by 2 y, plus y square, that is 3 by 2 y whole square. Okay, 7 by 5, that is 49 by 25 x square. Okay, plus anything is getting cancelled, you can cancel it. Okay, 2 and 2 will get cancelled here. This is 21 divided by 5 x into y, that is xy, plus 9 divided by 4y square. So this is the expansion of this. Let us check the next set of problems. Okay, now again it is the same identity. We are just replacing a and b values with different rationals or negative values and so on. Okay, now here a is equal to, let me write that a is equal to 2.5 p and b is equal to 1.5 q. Okay, now I can write this as 2.5 p plus 1.5 q whole square is equal to, okay, a square, nothing different here. Okay, 2.5 whole square, 2 multiplied by 2.5, that is p, with 1.5 q. Okay, plus q square is 1.5 q whole square. Okay, now it is a decimal square, but you can do it as 25 square, which is 625, and keep two decimals from right. Okay, and that will be 6.25, and as usual p whole square, that is p square. Okay, plus 2 into 2.5, that is 2 times of 2.5, that is 5. 5 and 1.5, that is 1.5 of 5. Okay, that is 7.5. Okay, 7.5 p into q, that is pq. Here also you can do 1.5 square, that is 15 square, 225. 2 digits from right, it will be 2.25. Okay, and q square. Hope you are getting it. Okay, let me write this below here so that there will not be any confusion. Okay, it is 2.25 q square. This is the expansion of this by using the same identity. Let us do it quickly for this. It is 3 by 4 s whole square. This is a square plus 2, again 3 by 4, it is a. And what is b? B is 8t plus 8t whole square. 8t is b here. Okay, now 3 square, that is 9 by 16 s square. Okay, and if there is anything getting cancelled, just cancel it. 4 ones are 4 twos are. Okay, 2 threes are 6, 6 twos are 12, that is 12 s into t, that is st. 8 eights are, that is 64 t square. So simple. Okay. Okay, now let us do this for x plus 1 by 2y whole square. Here it is x square. Okay, I don't have to write whole square, but you can write it because b is 1 by 2y here. Okay, let me write it as 2 into x, and it is 1 by 2y plus again 1 by 2y whole square. This is b square. Okay, 2ab. Now it is x square. This two will get cancelled, and what remains is x into 1, that is x, divided by y, plus 1 square is 1, and 2 square, that is 4, and y square. So this is the expansion of x plus 1 by 2y whole square. Okay, hope you are getting it. Okay, now let us do it for 1 by x and 1 by y. How you can do it? Okay, you can do it yourself, because let us don't waste time in doing the similar kind of things here. Okay, I'm just leaving you one problem. Just you can replace a is equal to 1 by x and b is equal to 1 by y. Okay, hope you will do that. Okay, now the second set of problems will be to resolve or to calculate the value of the given squares by using the same identity a plus b whole square. Okay, now let me write 64 whole square as 60, some roundabout value, okay, of 10s roundabout value or hundreds roundabout value, so that we can calculate the square very easily. That's why I'm writing it as 60 plus 4. Okay, now what is a plus b? A here is 60, so I can write it as 60 square, which is a square, and 2 into 60 into 4 plus 4 square. It is a square plus 2ab plus b square. 60 square, I can just do it as 6 square plus first, that is 36, and 0 0 square of that. Okay, that will actually give us 3600. Now 6 twos are 12, I can write it as 120. Now I can do that 6 twos are 12, 12 fours are 48, and we can keep it with a 0, that is 480, and it is 16, that is 4 square. Finally, you can just sum up 3600 and 400 plus, that will give you 4000, and 80 plus 16, that is 96. So that is 4096. 4096 is the value of the square of 64. You can verify that by multiplying 64 into 64. That will get you 4096. Let us do it quickly for 105. 105, I can write it as 100 plus 5. Okay, calculating 100 square is easy because it is in terms of the factors of 10 or 100, you can say. Okay, 100 square, okay, plus 2 into 100, that is a, and b is 5, and b square is 5 square. Okay, we can do it fastly. 100 square is 1 followed by 4 zeros. You know that, right? Because there are 2 zeros, if you square them, it will become 4 zeros. Okay. Now 2 into 100, 200, 200 into 5, that is 1000, another 1000 you can say. Here it is 10,000 and this is 1000, 11,000. Okay, plus 25. Okay, so it is 10,000 plus 1,000, that is 11,025. 11,025 is the value of 105 whole square. You can calculate that, you will get the same values. Now similarly here also it is 200 plus 5 whole square, that is 205 whole square. Instead of 100 square, it is now 200 square plus 2 into 200, that is 2a into 5 plus 5, that is 5 square. Okay, now 200 is 2 twos are 4 and followed by 4 zeros, that is 40,000. Okay, plus 2 into 2 4, that is 400. 400 into 5, that is 2000. Correct? Or else you can say 2 into 2 4, 4 5s are 20, 20 and these two zeros, it is 2025. Okay, it is already 40,000 plus 2,000, that is 42,000 plus 25, it is 42,025 is the answer for the square of 205 whole square. Okay, you can verify all these, or if there are any calculation mistakes in summing up the things, you can do that yourself. Okay, let us check if there are any other examples. Okay, now we are done with the exercise set 4.1. It was very simple. Now let us see the next concept, factorization of algebraic expressions using identities. How can I find out the factors of these algebraic expressions by using the identities only? Okay, now let us do that. Let us find the factors of algebraic expression x square plus 4x plus 4. Okay, you might have studied the finding the factors of the algebraic expressions in your previous class also by using a different method, splitting the middle term and doing all that. You might have done it. Okay, now let us do that by using this algebraic identity, a square a plus b whole square. Okay, now given is this expression, what is that? X square plus 4x plus 4. Okay, now let me write this as an expanded version of a plus b whole square is equal to a square plus 2ab plus b square. The right side part I'm going to write it as, okay, because I know the identity, and using that identity only, I have to find the factors of this. Okay, now listen to me carefully how I'm writing this, as I'm keeping this as x square only and just taking 2 only directly, 2, and doing it as, since I have considered a as x, let me write x, it is now 2a. Listen to me carefully. Okay, I'm writing it in the form of 2ab. Okay, now I've taken 2 directly as a constant and I know that a is x. I've written x. Now what I need in the middle term to make it 4x is 2. Correct? Now you can see that I have written this 4x as 2 into x into 2. I am considering this as 2. This is a, this is b. Now I can write this as b square. See how simply we have just done it in the form of a square plus 2ab plus b square. Hope you understood this. So what is this? What is this now? According to the identity is x plus 2 whole square. So the factors are x plus 2 and x plus 2. Okay, so you can write that. So the factors are, or you can say there is only one factor which is appearing twice. Factors are x plus 2 and x plus 2. Okay, hope you got this. If you multiply x plus 2 and x plus 2, you will get this x square plus 4x plus 4. You can do that yourself and see x into x plus 2 and 2 into x plus 2. We will do such problems in the future also. So this is how you will find the two factors x plus 2 and x plus 2 of this given expression by using the identity. This is a different method. Okay, let us see one more example. Find the factors of this. Find the factors of this. Listen to me carefully. How I am adjusting a and b and 2ab so that I can get a plus b whole square as my result, so that I can directly write the factors. Okay, listen to me carefully here. See, how do I write 36x square? 36x square, I write it as 6x whole square. You see that? 6x whole square, if I write it as 6 square is 36 and x square is 36. Sorry, x square. You understood this? So that I can easily get the value of a here. So that I can write the next term 2 into a. A, I already know a. See how simply I can do that. Since I already know the value of a, just after writing 2, I can write the value of a. Now what I want it to make it as a 12x here. It is already 12. See, 6 2s are 12 and 12x is already there. So what will be the value of b so that I can keep that value as 12 only? That is 1. And finally, I can write 1 square. Because I know the value of b here, I can directly write a b square here, and that should match the last term, square of the last term. Now here with this, what you can understand is here a is equal to 6x and b is equal to 1. Correct? Understood this? So therefore, what is this is a plus b whole square, and that is 6 plus 1 whole square. This is equal to this. So the factors are, okay, what are the factors? So the factors are 6x plus 1 and 6x plus 1. One more 6x plus 1. If you multiply these two factors, 6x plus 1 and 6x plus 1, you will get this algebraic expression. You understood this? Okay. This is how, by using the identity, I'm factoring it. Okay, now it's a little bit of different here. Okay, listen to me carefully. One simple additional step you need to do here. You see that 50p square and 18q square. Here in both a square and b square place, I don't have a perfect square so that I can write it just similar to here. Here a 36 was a perfect square, so I can be able to write 6x whole square. But 50 is not a perfect square. So what I will do is just divide this expression by 2, or you can say I will take 2 common out of this. Okay, take 2 common. Take 2 common from the expression. I will write it as, okay, when I take 2 common, you see that 2 into 25, that is 50, right? So if I take 2 common out of 50, what I remain with is 25, and 25 is a perfect square. Okay, why I am doing this, you understood, right? So if I take 2 out of this, it is 2 into 30. Okay, right? So it is 30 pq. 30 into 2, 60 it is. Now it is 9q square. See, I got another perfect square, 9. Another perfect square is 9. Now I just keep 2 aside and just consider this only. Okay, let us keep 2 as it is and write this as 5p whole square, that is 25p square. Now since I have a is equal to 5p here, I can directly write a 2 and 5p because that is 2a, and what is required for me to make it as 30pq. Q is required, 2 5s are, it is 10, and 10 3s are, it is 3q is required. See, 2 5s are 10, 10 3s are 30, p into q, 30pq. What I got as b here is 3q. You don't have to look at the last term at all because you already got b here. You can directly write this as b square, and that will be matching the third term, that is 9q square. Hope you understood this. So here a is 5p. Okay, I can write it as here a is 5p and b is 3q. Okay, so 2 is equal to 2 multiplied by 5p plus 3q whole square is the factor of this expression, or you can say 5p plus 3q and 5p plus 3q. So therefore the factors are 2. You should not forget this 2, okay, because it was there common in all the terms of this given expression. 2 into 5p plus 3q and another 5p plus 3q is the answer for this example 7. Hope you understood this. Okay, now let us quickly move to the next. Okay, now here comes another algebraic identity. If we replace b, if we replace this b, okay, by minus b, what happens? If I just replace b is equal to minus b, what happens? We will get another identity, and I hope you know this identity also, that you might have studied it in class 8. Okay, it is a minus b. Because I'm replacing b as minus b, I'm just replacing this symbol plus also with a negative sign, that is a minus b whole square. And since I am substituting minus b here, this plus will also become minus, and the whole identity, another new identity we will get, and that identity is a minus b whole square is equal to a square minus 2ab plus b square. What is the simple difference between this identity and this identity is the sign for the middle term, that is 2ab. Okay, that is negative in case of a minus b whole square. I'll not explain this anymore because you might be knowing this also. Okay, let us quickly see the examples based on this. Okay, before we visit the examples based on a minus b whole square, let us revisit the example one, that what we have started in the introduction section. Okay, you remember one example, there was one example where we took 3 consecutive square numbers, okay, added the first and the third square number and subtracted twice of the middle square. Okay, it is 2 into 4. You remember this, right? 10 minus 8, which is equal to 2. And I said this is an identity, so it should be true for all the values. So I cannot go on substituting the different values and prove it for all the values. I should be proving it in general. Okay, so I am taking in general 3 consecutive numbers. Okay, let us represent these 3 consecutive numbers as n minus 1, n and n plus 1. Okay, so it is generically 3 consecutive numbers. If you consider n as one number, n minus 1 is previous number and n plus 1 will be its next number. Okay, that way I am assuming these 3 numbers. Now let us take the square of the first and the third number. These are 2 numbers. Remember this. Okay, these are 2 numbers I am considering, and let me take the square of the first number plus square of the third number, that is n minus 1 square plus n plus 1 square. Okay, minus twice of the square of the middle number, that is 2 into what is the middle number, n, and the square of that is n square. You understood this? Okay, now why I have taken the proof of this example one which we started with, but I'm proving that now because now I know the 2 identities, a minus b whole square and a plus b whole square, so that I can substitute those values and the proof of this will be easy for me. You understood, right? Okay, now let me expand this n minus 1 whole square as a square minus a square, that is n square, minus 2ab, a is n here and b is 1, plus b square, that is 1 square. It is a minus b whole square. Now let me expand this as a plus b whole square, that is a square, which is again n square, plus 2ab plus 2a is n and b is 1, and plus b square. B square is again 1 square, minus 2n into 2 into n square, that is 2n square. Okay, now let us calculate this. N square, reduce this, 2 into n into 1, that is 2n, plus 1 square is 1, plus another n square, plus 2 into n into 1, that is plus 2n, plus another one minus 2n square. Okay, now what will get cancelled? Minus 2n plus 2n will get cancelled, and n square plus n square, that is 2n square, plus 1 plus 1, that is 2, and minus 2n square. You see, another minus 2n square plus 2n square will get cancelled, and what remained here finally is 2. So whatever three consecutive numbers you start with, the identity that adding the squares of the first and third and subtracting the twice of the square of the middle number will always get you 2. This is a proof of this identity, that what we considered as an example one. You understood this? Okay. So this is from the examination point of view, this is one of the important proof that you might be asked in the exam. Okay. Let us see. Visualizing the identity a minus b whole square is equal to a square minus 2ab plus b square. Okay, now as we have visualized or as we have proved a plus b whole square is equal to a square plus 2ab plus b square by using the geometrical shapes, let us visualize this identity a minus b whole square also. Okay, I've already drawn the geometrical shape here. This will be very easy to understand. Let us see that and prove this identity with the help of geometry. Okay, now you listen to me carefully. I have considered the whole length, the outermost length. It is little bit different from the previous proof, that the whole length of this side of the square I have considered it as a. Okay, you can see that, and this length as b. Hope you are getting this. Okay, now if this is a and this is b, what is this? It will be a and minus this, that is a minus b. So a minus b is this for me. A minus b is this length. You understood this? Similarly, if I extend this horizontal line just similar to the vertical line here also, this length will be a minus b, because the whole height of this square is a that I am considering. So, and if this is b, this will be a minus b for me. Now, how I am calculating the area of all this? Okay, let us see that now. See, the side of this square are a minus b and a minus b. So a minus b into a minus b, it is a minus b whole square, and this is what we want here. You understood this, right? Okay, now listen to me carefully. I have to first take the area of the whole square and subtract this area minus this area to get this area. Okay, geometrically. Okay, I'm asking you to think geometrically, that if I just want the area of this square from the whole big square, I have to subtract the area of this rectangle minus this rectangle, then I'll be left with the area of this square. Okay, so how do I write it mathematically? That a minus b whole square, you see that a minus b whole square is equal to area of the outermost square whose side is a, right? The big square, it is a into a, so that is a square, and from that a square I have to subtract this area and this area, the rectangle, this area and this area, yellow and red, that will get me the area of this. Hope you understood this. Okay, how did I got the areas of this and this here? You can simply see that this is b, one side of this rectangle, and this is a minus b, right? So this is parallel, so this is also a minus b for me. Okay, so it is b into a minus b, so that is how I got this as b into a minus b. Or this side, this is a and this is b, a into b, so that is how I got the area of that as b. Okay, you understood this? Okay, now what I'm doing is just to subtract this area and this area from the outermost area. So I will write it as a square minus b into a minus b, b into a minus b, and minus ab, minus ab, because I am subtracting just these areas of rectangles from the outermost area. And what is this? Just expand this, a square minus b into a, I can write it as ab only. Okay, and minus into minus plus, that is b square, b into b, b square minus ab. Okay, this is 1 minus ab, another minus ab, that will get me minus 2ab, minus 2ab plus b square. And that is how we got a minus b whole square is equal to a square minus 2ab plus b square. This is the proof of this identity by using some geometrical shapes. Okay, hope you understood this. Okay, now I think we have some examples based on a minus b also. Okay, now we have already spent about an hour of time in resolving these questions only. Let us keep this exercise set 4.2. Okay, but remember these two identities, a plus b whole square and a minus b whole square, where all these problems in exercise set 4.2 will be based on those formulas only. Let us meet in the next session to see the problems in exercise set 4.2. Okay, thank you.